welcome to the BSD Dev Room again.
Right. Oh, I started. Right. Hello, welcome everyone. When I switched from Windows to Linux, then Linux to FreeBSD for Studio, I tried to gather as much info about, well, whatever is needed for a FreeBSD Studio, music production studio, in one blog post called Sing BSD Sing. I was using FreeBSD for a year, and at that time I didn't know that a BSD is actually a BSD logo, not a mascot, not a FreeBSD. So it doesn't work. This doesn't work on all BSDs. I tested it only on FreeBSD, and I thought no one is interested in a studio based on BSD. But if you look at Twitter statistics, that's probably the most important thing I ever done in my life. And then it kicked off, and it's a pretty amazing studio. But let's start with who I am. As I'm pretty new in the FreeBSD community. My name is Goran Mekic. By now, I think everyone calls me Meka. And I come from a hackerspace in Novi Sad, Serbia, called Tilda Center. I was lucky enough to have a support from my beloved wife to actually do it, so we are co-founders. And I come from, my education is electronic engineer high school. I think that's the proper translation of our education system. And I studied something vaguely called business IT at a university, which actually translates to 80% math and the rest. I'm a band member, which means I play a guitar, which is the hardest instrument to record in a band, in a rock and roll band. I used to sing, but I hope I won't do it anymore because we have a guy who is actually trained in singing and does that way better than I do. I'm into, if you ask any person, they are listening to all kinds of music, but if we narrow it down, for me it's metal on guitar. Guitar music is usually metal, if you ask me. And there's this electronic music type called Gore Trance. So I'm not gonna go into, they say there are like 70 types of metal, but if you actually want to simplify stuff like I do, there are 3 types of metal. First one, tsin-tsin, chin-chin, and jin-jin. I'm playing the jin-jin style, and in electronic music there is uts-uts and pew-pew. I'm interested in the chickens, so of course the pew-pew style. But more elaborately, I like complex melodies and arrangements, so I needed something that is robust and works. So, let me show you a typical layout, or my layout in a studio. And this is it. This is everything FreeBSD or any operating system sees. It's ideally it's a USB digital mixer, so everything is in one place. The routing, the mixing, the effects, and whatnot, which you can control via computer. I'm not going to say FreeBSD because we still lack a bit of a support for devices, not audio-wise, but control-wise. And you probably need to hear what you're doing. So there are some speakers. There are some instruments that are recorded or sent through the USB so they can be recorded clean without any effects or whatever. There's a effects unit. Well, this is my favorite. So what does the mixer as a hardware does, it splits. One sound goes to the effects and one goes to the USB for recording. Then when the sound comes back, it's split again. So one goes to USB and one goes to the speakers. So it's a monitoring system. If you're playing or singing something, you can hear yourself. For the pew-pew part, there's a synth, and it goes straight to the effects processor. So it's from a mixer perspective, this is all one device. And there's a floor pedal board, so you can switch different presets on a effects board, on a effects rack. And what I usually do is use 3 sounds. It's clean, it's a jun-jun, and it's pew-pew. So in reality, this is how it looks. This together with a keyboard is a synth. The glowing yellow stuff is a processor, effects processor. On top there is a mixer, although it doesn't look like that. It's the mixer that's on the top of a pile there below the tripod. Luckily, we didn't need it this year for these dev rooms, so after the talk you can ping me and I can show you how it works and we can fiddle with it. And I don't know if you can see this, but this is a pedal board and something glowing here is a desktop. This is actually 10-year-old computer, so I have i5 with 8 gigs of RAM, and it used to run with a hard drive, now it's SSD, so it's a really, really low-end computer these days. And it's possible to use a low end thanks to FreeBSD being optimal in this way. So software that I use, or used, I started with FreeBSD, and it started all working after a lot of fiddling, because there are not many people you can actually ask how to run a music production studio. Later on I decided, okay, how about we go in totally uncharted territory. Nobody's using hardened BSD for a music studio. Let's give it a try, and that's what's installed on my desktop right now. It works perfectly, and for the sake of this talk, when I say hardened BSD, you can think FreeBSD and vice versa. There is this little audio driver on FreeBSD called OSS, and there is this little thingy called virtual OSS that does complicated things like resampling, routing, and whatnot. It's a user space program, because if you have a big number of channels, user space is more efficient in doing that kind of operations. RR5 is currently the only digital audio workstation available on FreeBSD that gives you the power to actually have a production studio. On Linux World, there's I don't even know how many alternatives, but right now I tried ported some of them, and they all have these Linuxisms, and it's really hard. So maybe in the future we will get alternatives. For the drumming, because I live in a building, and having a drum in a building is almost impossible, although I had it for years, and I don't know why I'm living yet still. Yeah. It was actually e-drums, so it's not a full analog drum. Probably that's why they kind of let me do it for a while. There's this thing called LV2, which is short for Let's Power version 2, and that's a framework and libraries for implementing your own effects and sound generators, or porting someone else's work. And there is Jack. Unfortunately, I personally don't like it, but currently Order 5 explicitly works only with Jack on FreeBSD, so we have to use it. And if you're talking about music, you're actually talking about FreeBSD real-time from a FreeBSD perspective. What does it actually mean? One is, if you pluck a string on a guitar, you don't want to hear it in 5 seconds, you want to hear it right now, so you have a proper feedback and you know what you're actually doing. And the second part is jitters. So if sample is not, put it shortly, if it's not on the sound card at the right time, you're not going to get your signal right. It's going to have these little distortions called jitters, and jitters are actually, from a real-time perspective, are harder to get than plucking a string. Everything below, I don't know, 6 milliseconds, no matter how your ear is trained, you cannot hear that. But 5 milliseconds, if your sample is late for 5 milliseconds, that's a disaster. So what does it mean? A lot of ccTL. First one is I joined Drum Gizmo team, and we have tests, and tests shown that the FreeBSD is so slow that tests are failing. It's not possible. I mean, if you read the FreeBSD, I think it's in a handbook, the kernel actually has a concept of real-time priority queue for the threads. So if your application is real-time, asking for real-time permissions, kernel is going to give it to them, only to the root, but there are ways to get exceptions. And what this does, I asked on a mailing list, the default is equal 5. When there's an IRQ, now I'm not a kernel developer, so I might be off, but from a musical point of view, when there's an IRQ in happening, the FreeBSD will not react right away, and because FreeBSD tries to save your battery, for example, on a laptop, and not reacting right away gives it ability to, okay, so I have these 5 IRQs, handle them in one sweep. Not entirely true technically, but that's what's going on. Lower this to 0, and every IRQ is handled right away. And the tests in Drum Gizmos magically started passing instead of failing. If you have USB audio, USB device, you can tune how many milliseconds of buffer is going to use, but only for USB. and it goes from 2 to, I think, 64, but nobody's interested in an upper limit, only lower one. When applications open sound device, they can choose the buffer size of the in-kernel buffers size, and it's also a buffer on the application because of the copying of the data. And if application doesn't know about that in FreeBSD, you can force it to be as real time as possible, and that's what latency equals 0 does. Give me the smallest possible buffer, so if, for example, Jack doesn't know how to handle buffers in FreeBSD OSS, okay, give it the lowest one. And the last one is a bit perfect. It's not strictly real time. It's more has to do with jitters, and if you know that you're not going to resample or in any way transform your audio in the kernel or virtual OSS, you can set it to bit perfect equals 1, and everything actually produced or written to the driver is just going to be sent to the device without taking any care of well, resampling for start. There are devices that actually can do hardware resampling, so they can use this too. And it's important if you have more than, I think, 8 channels on your audio. The reason I don't know is because I have 18. You have to use bit perfect and virtual OSS to do your audio stuff. So bit perfect is actually needed for a virtual OSS, and this is 1/4 of a command actually. What it does. So -s says, okay, if there's I'm working on 44.1 kilohertz, and there's something like 48K coming in, do the resampling, and then send it to the driver. -i8 is a real-time priority. B32 means use 32-bit samples, please. -S708 is experimental value for buffer. It depends on many variables, but mostly on your frequency of audio and what your hardware can push. In reality, this translates to few milliseconds on a very, very old computer, decade-old computer. You can say, okay, my card has multiple inputs and outputs, but please use only 2. This is what a C-2 does. And you can tell it with -m. Don't use first and second input, but use 8 and 9. Why I do that is because 8 and 9 for me is a FX processor. So if you're, I don't know, for example, talking on Viber, Skype, or choose your failure of VoIP, you can sound like Darth Vader or something because you're going through the effects. And as a matter of fact, a friend once asked me, who is not living in the same country as I am, okay, did you create something new on a guitar? Yeah. Can I hear it? Of course. And that's the way to tell your FreeBSD default inputs are the ones from a FX processor. -d DSP tells it create a device DSP /dev/DSP, and that's the default device in FreeBSD for audio. So if you got multiple devices or only one, doesn't matter. It's gonna create a default one for the device you're actually using. And this capital M thingy, the line, is copying my first input to the 8 and 9 outputs. What it actually does is when I play a guitar, I want to record it and send it straight away to the effects, and that's what it does. It's options for virtual OSS go to infinity, and it really does a lot of work in a studio. But if you choose FreeBSD for your studio driver, you're gonna learn, or whether you like it or not, you're gonna learn some non-musical stuff. There's gonna be a lot of GDB, unfortunately, or LLDB, choose your preference. There are all kinds of glitches and failures that can happen because the community running FreeBSD in Studio is really, really small. I think I can count 6 people that I met on internet since 2 years ago, I think. You're going to be part of that community. It's a small but a very, very fast answering community, and because it's really technical stuff, they are really technical. I don't know if I should count myself in. You're going to learn system administration, meaning you're going to discover a lot of ways to improve your real time by either managing, it's always managing buffers, but it's either managing sysctl, or you're gonna turn off some things, or you're gonna maybe compile your custom kernel. I don't use a custom kernel, so it works great. I don't think anyone should need it, but who knows. And when I said that USB driver has a tunable, sysctl tunable for a buffer, it actually didn't have it when I started. So I started poking around the kernel and trying to find which buffer is too big. I didn't know what I was doing. I was just lowering the numbers, and when I got the result, oh right, I can play now. So it's that buffer. So you're gonna learn kernel development at least a little bit, whether you like it or not, and you like it, right? Actually, I didn't do the sysctl for this USB driver buffer. I asked actual developer, can we please make it tunable? So it's an option. Maybe you don't know how to do development, you're just a musician, and you can ask people, can we do it like this or like that? You might have some idea how it's done. I promised you a lot of GDB, but I'm not gonna go into details of GDB. This is like 80% of GDB that I use. Why? Because if you imagine that the var in audio CPP is a variable holding your sample, and you don't get a nice voice out of your PA system, but you get, I mean, you never get a little distortion, you get, and you need to search why is that sample not right, and this is used like 80% of the time. You probably can use other techniques, but as it's audio, I didn't want to go into debugging too much. And probably dtrace would be easier to use, but I didn't use dtrace before. I used GDB, so I picked my known enemy instead of unknown friend. And it runs really nice, and I hope that in the following month we as a band will publish something on the internet, so it's not going to be totally empty talk. We actually do the recording these days, and it works. It works beautifully. So there are few things that at least I would like to be implemented or done next. There is this thing called Marlon. I started this as a library. It's in C++, and I wanted to explore buffer management in the audio application. I didn't know how to name it, and my wife suggested, how about you go to Google Translate, enter all the keywords for your software, and choose different languages, see what you like. For some reason, Irish language is beautiful for naming, because if you put I've put a buffer and chose all the languages, and almost in all languages buffer is buffer, audio is audio, music, oh my god. So I put buffer Irish, and it's Marlon. I don't even know if that's a proper Irish pronunciation, but that's how the software is called. It's currently running only on FreeBSD. Actually, it doesn't run anywhere, to be honest, because it's only the library, and if you know how the inner workings of the library are doing their stuff, you can program your own digital audio workstation, and that's where that's the direction I would like to take, as I don't know any other effort, and I asked to create a specifically FreeBSD audio workstation, but it's implemented in such a way that if you implement your for example, ALSA for Linux as a class, you have your ALSA input and output. And yeah, it's an experiment of using standard C++ library structures to do audio. You can be much more optimal than that, but I chose to go this way because if it works, it's less work for me. So it works wonderfully, so wonderfully that if I have two channels with one sample of buffer on the input and output, it takes around 30% of CPU on my computer, probably around 10%, 15% on a modern computer. What I'm not satisfied with is hardware mixers, digital hardware mixers. So in Tilda Center, we are exploring real-time operating systems and audio and ADDA chips. We want to implement our own digital mixer or audio interface because it's going to be equipped with a USB. And what I want to do with that is currently I use audio card to route my signals, which means virtual OSS does it. And if you look at the pathway, the signals goes to the hardware, then the kernel, then driver, then virtual OSS, then you route it and it goes back. It would be much more optimal if the routing could be done in the hardware, and that's what I want to do. As Tilde Center is conceived as an educational center, and I'm really loud about FreeBSD. Tuning and education of FreeBSD for sake of audio is what we do, and there are at least 3 persons listening to me, to my gibberish talks about, hey, what if we do this or that in audio-wise? And there's a Ravenna, I think that's the pronunciation, it's AES standard, and there's no open source implementation of that protocol. What that protocol allows or brings is ability to use your network for routing audio. So you can, for example, have multiple machines without audio card, but they all route their audio through Ethernet, and one machine does the reproduction of the sound. That would be really wonderful if we could have in a FreeBSD, and there are some FreeBSD developers that are tackling the problem slowly, and we hope, they hope that it's gonna be implemented soonish. I mean, with the drivers, it's never fast, so soonish. There are few people and teams I would like to thank. First one is Hans-Peter Salaski. He implemented USB stack for FreeBSD, USB audio drivers, virtual OSS, and I don't know what other plethora of software that is needed for FreeBSD to be a viable music production alternative. And he has even more crazy studio setup than me, so he needed more real time than me, so great. Yuri Viktorovich is a guy who ported almost all LV2 plugins. If you go to Freshports and type LV2, it's Yuri all the way. Tommy Pernilla helped me with presentation, proofreading, and some of the crazy setups for audio. Drum Gizmo team actually taught me how to do DSP real time and whatever is needed for audio, which 80% of the time means GDB. Order team really done great stuff. It does wonderful audio mixing and routing, and not so wonderful MIDI, but it's usable. It's still used in at least my studio, but it can be better. And a Tilde Center crew for supporting me, giving back ideas, implementing a few bits and pieces, and generally not being annoyed by me when I talk about this stuff. That would be all. And if you have any questions, yes?
Do you use this setup only for recording music, or are you also using it to mix in the box, basically with plugins like, I don't know, virtual instruments or compression EQ?
So the question was if I use it only for mixing, or there are some effects in the box. The effects are good. but sound generators are not so good. For example, there's I would say a crossover called Guitarix, which doesn't generate the sound, but if you need a metal sound, it's going to generate a totally different sound on the output because of the distortion, and it's still not really good. For rock and maybe clean sounds, yeah, but sound generators are not perfect, effects are wonderful, and sometimes I use software, sometimes I use direct. Yes?
Do you think it's a better idea to use FreeBSD than Linux?
Yes, actually, the reason why I switched from Linux to FreeBSD is that I didn't switch actually. I had a dual boot, and FreeBSD was in a worse situation because it was on a hard drive. Linux was on SSD. There is no such thing as a real-time queue for threads in a Linux kernel or preemptive threads. There are patches, but when I used it, VirtualBox broke. So it's better for real time, but you probably have much better support in Linux for other audio workstations like Muse, which I would really like to have on FreeBSD.
What about Firewire? Is that the kind of...
I try to avoid it by all means. I don't know. I mean, even on Linux it's a problem, so I never tried it. There was.
Is there a website where we can hear some of your music?
Yeah, sure. There's one song on SoundCloud, so if you ping me on anything, I will send you a link. I wanted to put a link, but it's a huge. Anyone else? Be loud, now it's the audio time.
You were saying I was a little bit lost with your way of using the effects processor. You're basically sending the clean guitar signal to the box, to the input, and then you have the effects processor as a send and return?
Actually, almost yes. What I do is, let's say it's a guitar. When I play, it gets into the virtual OSS, which splits it in two. So one goes to the computer for a recording, because you want to record the clean sound and then re-amplify it and whatnot. And the other half of the split goes to effects, because you want to hear it in real time while you're playing. But when samples return from the effects processor, go to recording to the computer and to the PA.
Yeah.
We have a minute and a half to be loud. Okay, that would be all then. Thank you for coming.